Hi learners, it's week 13 and it's our final week of machine learning. This week we'll be covering probably the most important lesson of all, even though it only takes up half a lesson, which is the application of machine learning in the real world, or ethics. Ethics is the most important branch of machine learning now, as the impact of machine learning is felt everywhere, and its influence is even more profound than what we can imagine currently today. We have to make sure we get our algorithms and our data done correctly in order to make sure the impact is the way we want it to be, and that we're in control of what we want our outcomes to be for our algorithms. Let's look at this important aspect today.
So as usual, let's recap what we've done in the past week, and then forecast what we're going to do for this half of the lecture. So last week, we looked at reinforcement learning, this idea of another paradigm in machine learning where we get occasional feedback but no direct supervision on our problem. That is, we have X's but no Y's. We get occasional feedback, but they're not directly Y values. We saw that actually there are some components of a reinforcement learning algorithm that are key. For example, the policy, or what we're going to do at each particular state, the reward, meaning some type of value of being in a particular state or taking a particular action within the state, and information about the action that we can take, as well as the observation or state information that we can have as a result of that. And occasionally, or in certain models of reinforcement learning, we'll have a model. So the model can be for what the agent can do, as well as for what the environment, how the environment reacts to our particular work. We also introduced the idea of the Markov Property. It's a very key concept in being able to model things in an efficient manner, where we collapse the entire information history about what has happened prior to the current time step into the current time step. So we're going to write all of the history from 1 to time t and say it's encoded by our state S of t. Okay, so basically this current time step t is all we need to know in order to make future decisions, including the one at this time step. And we're going to use this concept to define a series of different types of things, Markov chains, Markov reward processes, which add a reward to the Markov chain, and then a Markov decision process that further adds the idea of making a conscious decision or action to the Markov reward process. Okay? Then after this, we understood a series of different types of Bellman equations, both the expectation equations as well as the optimality equations, that give us a recursive form for calculating the value of being in a particular state, which is our V functions, or a particular action, which is our Q functions. So here we've illustrated one version where this is the optimal Q value, or the optimal value for taking a particular action at a particular state, and recursively defining that through the idea of a state value function, and then the subsequent Q value function. So here we have this equation, which basically says for a particular state and action, that optimal value for this will be calculated as the immediate reward at a certain time step. Okay, this reward here that the environment gets to reward us with, plus a discounted future reward, which is going to be based on the Q value for the next state, the next action within the state. So this is going to be dependent on us from our policy. So we always want to choose the one that's going to maximize our return. So there's a max there. And then the probability transition matrix, which basically says how the environment is going to react to us doing an action and which state are we going to land on. So going from state S to state S prime. So this week, what we're going to be looking at are ethics. We want to get an idea of what are the issues here in terms of fairness, accountability, and transparencies. And this is really important because, as we said at the beginning, having an awareness of how machine learning in the larger context affects real people is important because we want to model things in a transparent, accountable, and fair way. And most of the time, we don't have particular reasons why we would want to have a bias or not have fairness, accountability, or transparency. But by certain problematic design decisions, this may come about inadvertently. So we want to understand what systematic shortcomings or problems in machine learning happen in the stages of data gathering, preparation of the data, and for us, the model learning. Okay, which algorithms do we pick? So this week, what we'd like you to do is watch a particular YouTube video on the weapons of math destruction. It's a catchy title, and it goes by the same acronym WMD. But in this case, we're looking at what happens when machine learning and data science have some particularities that could engineer bias into our algorithms. And bias not in the machine learning way, but in the way that we think about in the common sense way of biasing against or for different particular people or ethnicities, for example. And to do that, we're going to watch this video from Kathy O'Neill. And I'd like you to watch the video in conjunction with doing the exercises in the Collab notebook. Okay? So also, when you're reviewing the slides for the pre-part of the lecture later on, you're going to need to stop through part of the lecture and fill out the remainder of the pre-notebook before you continue. So please take note of the stop sign in the class notes and then finish the Collab notebook, the pre-part first, and then you can finish the rest of the lectures. Okay? See you on the other side.